Hi, this is Mr. Manley. This video is for people who are already familiar with the law of sines from geometry or maybe from an intermediate algebra class. We're going to look at using the law of sines to solve triangles. When we talk about solving triangles, if you look at this triangle to the right here, solving triangles means that we are going to find the measure of all of the angles, A, B, C, and find the measures of all of the sides. And you will recall that the angle measures get capital letters, and then the side opposite each angle is going to be labeled with that corresponding letter. I'll give you a bigger letter C here. So I got a capital C here for that angle and a lowercase c for the side that is opposite that angle. Solving a triangle means finding the measures of all the angles and all of the sides. Okay, so here's a case where I have been given some information about a triangle, angle A, angle B, and side A. And that's the first thing to know, is that we need to be given, in order to be able to solve, to do this solving of a triangle, we need to be given at least 3 pieces of information. And we can almost be given any combination of 3 pieces. The only case where we would not be able to solve the triangle from the 3 pieces of information that make a triangle would be if we have 3 angles given, because in that case we don't have a unique triangle. So here's a case where I have A, B, and side, angle A, angle B, and side A. And my recommendation is that we always draw a picture, because if we draw a picture and we do that to an approximately accurate scale, then we're going to have a built-in check for the problem. So here I'm going to put this angle A here. That's probably a little bit too big for angle A. It's more than 120 degrees. So let me try and change that, bring that down a little bit, maybe around here for angle A. Now I want angle B to be 41 degrees. I'm going to put that down on the right side here. So you see I'm going to take this angle here and I'm going to put it at about 41 degrees and then extend it until it meets the opposite side there. So let's see about labeling that. That's angle B, which is 41 degrees. And then side A over here on this opposite side, opposite from A, that is equal to 10. And the objective here is to solve and find out what is angle C, what is angle C, what is side C, and what is side B. Well, maybe you can see that the solving for the angle C is easy because we have the 2 other angles. So it's just the rule of 180, right? You should know that. The rule of 180 is that there are 180 degrees in a triangle. Therefore, angle C is 180 degrees minus 123 degrees minus 41 degrees. And that gives us angle C at 16 degrees. Now, in order to find the sides, I'm going to have to go back here and use the law of sines. Stated here that side A, the measure of side A over the sine of angle A is equal to the measure of side B over the sine of angle B, etc. So let's go ahead and look at doing that. I'm going to solve for side B here. So I'm going to say side B, and I'm going to set up B over the sine of B, and the sine of B is 41 degrees, so I want the sine of 41 degrees, and that is going to be equal to side A, which has been given, over the sine of angle A, which is 123 degrees. And then solving for B, I am going to simply multiply both sides by this sine of 41 degrees in the denominator on the left side, And I'll have an expression that I can key in and find, and I'll write that answer over here. Getting 7.8. And if I look here, up here, and I say, and I write that in, 7.8, and I look, and that makes sense, that this could be 7.8 if this side is 10. And like I said, I have a kind of built-in check if I've drawn things to an approximate scale. I'm not going to solve for side C because that would be, it's just the same process, right? I do want to look at what I was given here. I was given an angle, and a side. So I do want to look at this idea. Looking at this general triangle, we were given angle A, angle B, and side A. And I looked, and I was given this angle, and this side. And let's write that down over here, that I was given an angle, and a side. Let's just look at all of the possibilities of what I could be given. I could also be given a side, and a side. That would be one idea. So you can think ahead and go, okay, what other information could I be given? I could be given an angle, a side, and an angle. I could be given a side, and an angle. I could be given a side, an angle, and a side. And I could be given an angle, and an angle. These are all the possibilities for 3 pieces of information that I could be given. Now, we've already said that we cannot solve this angle. That does not indicate a unique triangle. For instance, I could just draw, if I take this triangle that I was given, I could just draw another little triangle inside it that has the same angle measure, but they obviously, there's no specific size, there's no unique value to the sides that we could solve for. Looking at the one that we just did, this angle side, we were able to solve that. Also notice that both of these, AAS and ASA, we could always begin with the rule of 180 on those because we are given 2 angles. And then the other thing to note at this point is just that this SSS here, the second one, is going to require the law of cosines, which can be talked about another day or with another video from myself or another source. And this SAS is going to require the law of cosine. So this is all of the combinations of 3 that we can be given. We have this nice easy piece of information we can get here using the rule of 180 if we have been given 2 angles. We know that we have to use law of cosines for a couple of these if we're going to solve them. And then, of course, this is going to be a law. This one we're going to be able to do with the law of sines as well, the SSA. So that's all I'm going to look at for this video. Another video that you want to look for from myself or another source is this. SSA is going to produce something that is called an ambiguous case. And that's something that I'll talk about in another video, or like I say, you can look for that from another source.